Hello guys, welcome to this video. I was previously solving this paper 0478 February March 2020 0478 variant. So I had completed question number 1 and question number 2a in my previous video, but then there was a video making issue at my end, so the video was stopped. So this one is part 2 of this question, and I'm going to repeat how I did this for your help. Okay, fine. So you can watch my previous video for the previous parts of the question. Okay, parity bits are used to help. This is question 2 part B. Parity bits are used to help detect errors in data transmission. A parity bit is added to each binary value before transmission. 3 binary values are to be transmitted using even parity. Now you have to complete the parity bit that would be added to each binary value for even parity. Okay, so over here you have to make sure you have to count the number of ones, and you have to make sure that the number of ones are even. So this is the key point that you need to keep in your mind while solving this question. So here, as I did before, I have to count the number of ones. 1 2 3 4 5. 5 is not an even number. This is primary school mathematics. So so I'll add one more 1 over here to make it 6, which is an even number. So then it would be an even parity. So 1 2 3 4 5 6. Now over here we have 1 2 3 4. This is 4. We have the number of ones as 4, and 4 is an even number, so we don't need any other 1 over here. So I'll just add a 0 as my parity bit. Now over here we have 3 ones, which means that 3 is not an even number, so I'll add one more to make it 4, which is an even number. Now question part 2 says that a number of errors occur during data transmission. Okay, now it says you have to state why a parity check may not detect data transmission error. So you have to describe, you have to state a situation where parity check may not detect transmission errors. So if 2 bytes have changed places, maybe this one was here and this one, there was a transposition error, right? So it's not possible to detect that where the error lies. So you just have to state, so you'll write that in case of transposition error. Okay, now part C of this question says that data is encrypted using 128-bit symmetric encryption before it is transmitted. Okay, so it is long key. Fine. Then explain what is meant by encryption. So you have to just state, you have to provide 2 valid points for this. So for this you can write that it is a security method that applies an algorithm that makes your data meaningless, and your plain text is converted to ciphertext. Okay, and data secured by encryption needs a key to be encrypted and decrypted. So you can either write 2 of these points over here. So you can write that it is a security method, that applies an algorithm to make data meaningless. Okay, so you have to make sure that data is meaningless. This is the keyword. Okay, and then plain text is converted to ciphertext. You only need 2 points, so I think these is as far as 2 marks are concerned, that this is okay. Otherwise you could also write about that data secured by encryption needs a key to be encrypted and decrypted. So now part 2 says state how the strength of encryption can be improved. So to improve the strength of encryption, you can increase the size of the key. Okay, so you can write that increase the size of key. Okay, now part D of question number 2 says that describe how the school could prevent the loss of stored data. So now you have to it's a 6-mark question, so you need to describe some methods that could be prevent the loss of stored data. So firstly, it's about you always write in such cases strong passwords, because these are this is a very easy method to protect your data and prevent the loss of your stored data. So you can write that it could store data with strong passwords. Now you have to state a reason, and then you have to obviously explain it. Okay, so you can write that to prevent unauthorized access, to prevent unauthorized access. Okay, because of course strong passwords would prevent your unauthorized access to your data. Then you can also install your antivirus software, because it would detect for any virus present that could corrupt your data. Okay, so you can also write that it would you can install an antivirus software. Okay, so as it would detect any virus present that could corrupt your data, corrupt the stored data. Okay, and then you can talk about strong passwords are done, then antivirus, and then you can talk about maybe a firewall, because installing a firewall would help monitor the incoming and outgoing traffic. Okay, so you can write that it could installation of a firewall would monitor installation of a firewall, as firewall would monitor incoming and outgoing traffic. Okay, and obviously it would it would block any traffic that does not meet given criteria. Okay, it would block any traffic that does not meet a given criteria. Okay, so like 3 things are discussed and explained. You can write you could also write that then you can also write about use of backups. Okay, that if data is lost, it can be replaced. Okay, so you can write that. Moreover, use of backups would be an option as in such a case, when your data is lost, it can be replaced back. So you can write that as if data is lost, it can be replaced. Okay, would be an option, as if data is lost, it can be replaced. Okay, now question number 3. It says that Priya studies music at school. She is buying a new computer to complete her schoolwork at home. Priya has a choice between an internal hard disk drive (HDD) and an internal solid state drive to store data. Now you have to give one similarity between an HDD and an SSD. So the one similarity between them can be they're both one. You cannot write that they're both internal because it's already given. So you can write that they're both non-volatile storage. Okay, they are permanent. So they are non-volatile storage. Okay. Now you have to explain three differences in part 2 between an HDD and an SSD. So number one, you can explain that HDD is less expensive than HDD. Okay, sorry, HDD is less expensive than SSD. Okay, so because it's a newer technology and it's an older one, so obviously the new one is quite more expensive than this old one. So you can write about that. HDD is less expensive than SSD. Okay, then SSD, which is more expensive. Okay, which is more expensive to more explanatory. Okay, then for part for the second point, you can write that this is a famous a fact about HDD, that HDD has moving parts, while SSD does not have any moving parts. It stores data by flashing it onto the chips, and data is controlled by the movement of electrons within these chips. So while HDD is it has moving parts, right? So you can write that HDD has moving parts, while SSD does not. Okay, then you can write about the fact that HDD, as it is an older technology, it has a slower data access than SSD, because SSD is an updated version, and obviously it is more faster than HDD. So you can write about the fact that HDD has a slower data access than SSD. Okay, so these were the three differences. Now question 3 part B says that Priya needs to transfer file between the school and her home computer. Okay, so now you have to identify one offline storage device she could use to transport these files. Okay, it's talking about one offline storage device. It's between the school and her home computer. So we usually use this USB. It is common method of transmission of files, and it is an offline storage device. It is basically USB flash memory. Okay, so you can write about it. It's not a USB cable. It's basically a USB flash memory drive. Okay, so you can always write about this. Then part C says that Priya is using a sound editing software to record and edit different music tracks. Now you have to identify two input devices that she would use for this task. So now she's recording, fine, and editing different music tracks. So for the recording, she needs to have a microphone. Okay, and for the editing, she needs to have a keyboard, basically, because obviously she have to work with all those typing and stuff, and so keyboard would be a good option as an input device, right? And then two output devices. Okay, so since she's recording, okay, she's using a sound editing software, and there are different music tracks, so she needs to hear them as well. So that could be a loudspeaker, okay, and a monitor, of course, because when she's editing it, she's obviously doing it, this monitor is there, the speaker is there, and she's a microphone to input the tracks, the voices. Okay, and then she has to record it as well. So I think these are the appropriate devices according to the situation that is given. Okay, Then part D says Priya shares her sound files with other students. Okay. Before sharing the sound files, she compresses the files using lossless compression. So you have to describe how lossless compression reduces the size of a sound file. So whenever this compression thing is used, I always say that you get a mark, like 1 mark is always awarded for writing that it uses compression algorithms. Okay, it uses compression algorithms. Okay, and for the second point you could write about, because they're talking about lossless, so you could say that the original file can be uncompressed again. Okay, the original file can be uncompressed again. Okay, then E part of this question says that Priya currently uses MIDI files to store her data. MIDI is basically musical instrument digital interface, and Priya's friends have asked her if they can have an MP3 version of the file. Now in part 1 of this okay, you have to give 2 features of a MIDI file. Okay, now you have to give 2 features, so you don't need to actually write that it is musical instrument digital interface file. No, now you have to tell its features. So it's basically a fact that it is an instruction of how to make sound, and it is non-audio recording. Okay, so it is basically produced by a synthesizer. So you need to have 2 features over here, so you can write that instruction of how to play sound, and then you can write about that it's non-audio recording. Non-audio recording. Okay, pretty simple then. And now you have to give 2 features of an MP3 file. Now MP3 file, you don't need to write the full form, just need to describe the 2 features. So it's it's recorded by the microphone. MP3, the files you're viewing, the videos, these are basically usually in MP3 format or in MP4 format. So here you can write that it is produced by the microphone, and yeah, it's recorded by, okay, it's produced by the microphone, or you can write that it is recorded by the microphone, because you basically recorded by the microphone, and that it is digital recording of sound. So this is good enough. Now question 4 says that assemblers, compilers, and interpreters are types of your translators, right? Now you have to tick to show that which statements apply to each translator. Each statement may apply to more than one type of translator. Okay, let's see one statement at a time and think if it applies to all of them, or one of them, or 2 of them, whatsoever the situation is. Okay, translate low level language to machine code. Low level language to machine code, it's basically an assembler, because compiler and interpreter, they deal with high level languages as well. Okay, they don't need deal with this thingy, okay, this conversion. Then translates high level language to machine code. This is basically this compiler and interpreter, okay, because they are translating high level language to machine code. And produces error messages. Yes, these both produce an error messages. The only difference is that while the translation, the program is executed one by one, right? So each time it detects an error, it stops. I'm talking about the interpreter over here. So it stops, the execution stops, and an error is given that in this line the error is here. So once the error is corrected, then the other lines of the program are continued to be translated. But in the compiler, an error report is produced at the end, but both produces an error messages. This produces at the end, while this produces while the execution of the program is being done. Okay, then translate high level language one at a time. So this is interpreter. Then produces an executable file. This is a fact about compiler, right? Okay. Now question number 5. It says that programmers can use denary and hexadecimal values. These values are stored in a computer system using binary. Now, in a part, you have to explain that why binary is used to store data in a computer system. Okay, now explain why binary is used to store data in a computer system. So, basically, you have to provide 2 points over here. So a computer consists of millions of, computer, we don't see it, but yes, inside the computer's body, we have millions of transistors and logic gates within the computer, which are either in the on state or the off state. And these on-off states are then processed by zeros and ones. Okay, then it could be 0 and 1 only, because you need to have only 2 states, right? So these 2 states are either represented by 0 and 1, and that's why you need only base 2, and this base 2 is represented by this binary. Okay, so for the first point, you can write that computers consists of millions of logic circuits. Okay, logic circuits, which are either in the on or off state. Okay, so these on-off states can be processed by ones and zeros only. Okay, so you need to basically talk about that how these on and off states can be processed, and then the fact that computers consist of millions of logic circuits. So you need to be aware of the hardware of the computer as well, as we have learned in chapter 3 that computers consist of logic gates. So now question 5 part B. It says that complete the table to show. Okay, let's put it over here. Complete the table to show how the denary value would be stored as binary in an 8-bit register. Okay, fine. Now this is basically denary to binary conversion. So whenever it is talking about binary, you need to put up the place values for all conversions basically. So 1, 2, 4, 8, 16, 32, 64, 128, because these are 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. So you need to go till 128 only. Now it is 129, so it's pretty simple that 128 plus 1 is 129. So just 1 over here. We ignored the zeros. I'm just writing it to make it 8-bit value. Of course, I cannot leave this place empty. Then 56 is let's work out that what numbers add up to 56. Okay, so the working space is given over here. 32 64 is vague for this thingy, so let's do it. 32 plus 16 is what? 48. Now you had if you subtract 56 from 48 from 56, so it would be 8, right? So you just need 8 more. If you add 8 to 48, it would be 16 and 56. So it's pretty simple that over here it would be 0, then over here it would be 0, then 32 plus 16 plus 8, and others are all 0. Now this would give you 2 marks. Now part C says that complete the table to show how the hexadecimal value 3A9 would be stored as binary in a 12-bit register. So make sure that if 9 is on this side, okay, if 9 is on the right hand side, so then it would be on the right hand side in the binary presentation as well. And if A is in the middle, it would be in the middle, and this would be at the 3 would be at the left hand side. So now let's do it. I will place the place values 1248, 1248. Now 8 plus 1 is 9, 0, 0. A is 10. 2 plus 1, 3. And then 8, 9, 10. And 8 and 1, 9. We know that A is 10, right? So now identify 2 uses of hexadecimal values in computer science. Okay, so you can write any 2 uses. We have multiple uses in our book, okay, which are given, but you can write about the fact that they're used in MAC addresses, or maybe your memory dumps, or these HTML color codes. You can write about any one of them. Okay, HTML color codes, MAC address, HTML color codes. Fine. Then let's move on to question number 6. So here you have this logic gate question. Question number 6. Part A says that you have to complete the truth table for the given logic circuit. Do not attempt to simplify the logic circuit, so you don't need to do this. Okay, they're making things easier for you. Now let's identify the gates first and their inputs one by one. Okay, this is what? This is an OR gate. Okay, we have the inputs, 2 inputs, and OR is AND. So A is OR with B, right? So these are the inputs over here. Then this C is NOT. This is basically the NOT gate. You need to learn the shapes of these gates. So it means it's C bar, and then it's going to be, this is AND gate, but this thing, this hole, if you remove this thingy, this circle, then this hole is this AND gate. But if this is over here as well, then it is NAND. Okay. So it is B dot C, because it is, first it is being AND, and then this, because of this thing, it's NAND. So it'll, put this bar over here because the whole input is, then bar, of course. And then this thing is pretty simple. This is AND. Now you have to make both of these multiply together. So dot B dot C bar, and then this is going to be your final output X. So without wasting further time, we're going to draw the truth table. It's going to be first A plus B, and then C bar, and then B dot C bar, and then B dot C bar, and then X is basically what? It is A plus B dot C bar. Okay, then A plus B is 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, 1, 0 plus 1, 1, 0 plus 1 plus 1, 1, and 1 plus 1 is 1. And then C bar is basically whatever this C is, you have to do the opposite of it. So it's 1, 0, 1, 0, 1, 0, 1, 0. Okay, 1, 0. Then B dot C bar is basically this: 0 1s are 0, 0 0s are 0, 1 1s are 1, 1 0s are 0, 0 1s are 0, 0 0 are 0, and 1 1s are 1, and 0 1s are 0. Now you have to make it the opposite. So it is gonna be 1 1 0 1 1 1 0 1. Okay, 1 1 1 0 1. Now what you have to do is you have to AND it with this, right? So it's gonna be 0 1s are 0, 0 1s are 0, 0 1s are 0, 1 1s are 1, 1 1s are 1, 1 1s are 1, 2 1s are 0, 1 1s are 1. So this is basically the output X of your logic gate, without any simplification, right? Okay, so let me put it back. Now I have to do the drawing of this gate basically. So let's check out this question. Okay. A water control system uses a switch and two pressure sensors. Okay. The outputs of the switch and the sensors are shown in the table. You have to create a logic circuit that will produce an output of x, output x of 1 means it would be on. Okay, 1 means on. And when switch S1 is on, okay, switch S1 is on, it means that S1 is on bar. Okay, it's like 1, S1 is 1, S1 is equal to 1, it means it's not bar. If it is 0, then it is bar. Okay, and now n means multiply. Either P1 is less than 3. Okay, P1 is less than 3, it means less than 3. Okay, this is less than 3 and this is greater than or equal to. These are the inequality signs in mathematics. So P1 is less than 3. So yes, it has an output of 0. So P1 is 0, or okay, either, it says either P1 is 0. Wait, let's check first, then we're going to work out with it. And P2 is less than 3, less than 3. So P2 is equal to 0, but not both. Okay, wait, either we have to understand it carefully, it looks tricky. You have to talk about, they're talking about the fact that either P1 is less than 3 or P2 is less than 3, but not both. Okay, they both can't be 0. Okay, so now the main confusion comes here, that maybe it would be P1 plus P2 and then not. Okay, but if we use NOR gate for them, NOR gate, this is P1, this is P2. So let's see if these are 0 1 1. Let's draw a truth table. Okay, what would be the output with your NOR gate? 0 plus 0 0 1, 0 plus 1 1 0 0. Now wait, they're saying that either P1, it would give an output of 1. Now this thing, this NOR thingy, is then AND with S1. Now where is S1? Okay, wait, then wait, now we have to, okay, I had to draw a bigger truth table, so let me erase it. Okay, S1, P1, okay, then P2, and then if you're going to do this P1 NOR P2, like I'm going to use the NOR gate if in that situation. Now it's basically 2 to the power n, we have 3 inputs, 2 to the power 3 is 2 to the 4 to 8. Okay, so let's draw a truth table. So 1 2 3 4, 1 2 3 4. Now you have to half the number 0 0 0 1 1 0 0 1 1, and then 0 1 0 1 0 1 0 1. Now if I what do I do is I first NAND these both. Okay, 0 plus 0 0, it's going to be 1. 0 plus 1 1 is going to be 0. 0 plus 1 1 is going to be 0. 1 plus 1 is 0. 0 plus 0 0 1. 0 plus 1 is 1, so it will be 0 0, and this would be also 0. And when I would AND it, I would AND it with S1, so it would be what? AND with S1, so it would be 0 1s are 0, 0 0s are 0, 0 0s are 0, 0 0s are 0, 1 1s are 1, 0s are 0, 0s are 0. So everything is 0, and it's given the output of 1 when both are 0. But they're saying but not both, so we can't use this NAND gate. Okay, we cannot we cannot use this NOR gate. Okay, so now if we check them out with then we have opposite, we have NOR, or we cannot use over here, of course. Now let's do it with XOR. Okay, let's do it with XOR. Let me erase it. I'll do it at the back side. Okay, let me do it with the XOR gate. S1. Okay, let's use a pen. S1, P1, P2, and then if I XOR P1 XOR this P2. Okay, and yeah, one more thing that it's gonna be XOR, but I have to put bar on them, because bar for the fact that wait, I didn't put bar over here, but even in that case you can work out yourself that you won't get the right answer. Okay, now I'll put them bar on over here as well, but first let's do it separately. Okay, because P1 was 0, right? So that's why, and P2 was also 0, so you need to put the bar over here. Okay, and then P1 XOR P2 bar, right? Yes, so let's do it. So you have 2 to the power n is the inputs. We have 3 inputs, right? So 2 to the power 3 would be 8. So 0 0 0 0 1 1 1 1. Okay, then 0 0 1 1 0 1 1 0 1 0 1 0 1 0 1, and then P1 would be what? So it's 1 1 0 0 1 1 0 0, and P2 would be 1 0 1 0 1 0 1 0. Now when you're going to XOR these both, so it would be same 0 opposite 1. Okay, same 0 opposite 1, right? So this is opposite 1, same 0, opposite 1, and same 0. When I'm going to add this thing with your S1, so it's gonna give me what? Let's see. 0 zeros are 0, 0 ones are 0, 0 ones are 0, 0 zeros are 0, 0 zeros are 0, 1 ones are 1, 1 ones are 1, 1 zeros are 0. So it's given an output of 1 when 1. Let's check then where the output of 1 is given. Here the output of 1 is given when P1 and P2 is not the same. They are not both 0 over here. So that's why you can use an XOR gate. I hope it's clear enough. So now what we're going to write, the algebraic statement over here is going to be the final statement that S1 is dot with P1 XOR P2, P1 bar XOR P2 bar, because it was 0, right? So this was it. Okay, now let's do it. S1 is dot it's AND with P1 bar and then P2 bar. First let's draw the NOT gate for it first, because they were initially 0. Okay, and then again P2. Now they are gonna be XOR, okay, together. Okay, so this one is the XOR gate, so you need to carefully know it. Let's remove these previous papers. Okay, fine. So this is this. Okay, and then you have to AND it with this S1. So it is gonna be this, and this is gonna be this, and it's gonna come a bit down. So I make it with the AND gate over here, right? And then it's gonna be this, and I'm going to join it with X somehow. So yes, this is your logic gate, and I hope it's clear. You can always make a truth table when there are confusions in our minds, so you can always make a truth table for assistance. Okay, then let's move on to question number 7. A room has an automatic lighting system. Electric lights are automatically turned on when a person enters the room. Okay, wait, now understand the scenario first. These lights are automatically turned on when a person enters the room, and the natural light level in the room is less as 10 or less. Now you have to explain, this is a 7-mark question over here. Explain how your sensors and microprocessor are used to control the electric lights in the room. Okay, so basically you have to identify the first step in such type of question. You have to identify that what sensors are being used. So you're going to write that for the first part. You're going to write that light sensor. Of course, for light sensors are going to be used to sense the natural light level, and for this, when a person enters the room, it would be a motion sensor. So, and motion sensors are used. Then what? The same traditional steps for all these sensor questions. So you write that sensor sends data to the microprocessor. Okay, this is to specify which data, analog or digital. Analog data to the microprocessor. Now what happens that ADC in the microprocessor converts analog data to digital. Okay, these are the two traditional steps, and then you have to write that yes, and this one is also a traditional step. Okay, that microprocessor then compares the values of data with the stored value of data. Okay, microprocessor compares these values of data with the stored value of data. Okay, first of all, your motion value is checked, right? Because obviously the lights are turned on when a person enters the room. So first of all, the motion value is checked. Okay, at first the motion value is checked. Okay, because it the lights operate when a person enters the room at first, right? And they're turned on. Okay, so first of all, the motion's value is going to be checked, and then if motion value is is in range, okay, it's the same, then the light value is checked. Of course, at first the motion value is checked, and if this value is in range, then light value is checked. Okay, and then you have to write about the fact that if the value of light is less, then you have to identify the fact that natural light level is 10 or less. Okay, so then if the value of light is less than or equal to 10, then your lights are then microprocessor sends signals to the actuator to switch on the light, because the microprocessor basically itself sends signals. It does not itself switch on the light. So you'll write that if the value of light is less than or equal to 10, then microprocessor sends signals to the actuator to switch on the light. Okay, now for the 7 point, you can write that that otherwise the process continues in a continuous loop. This is also another traditional step in your these sensor questions. You can write that otherwise the process continues in a continuous loop. Okay, you can actually make a flow chart of this thing, this whole process, and then you can easily see it. Now this one is the last question of this paper, question number 8. A student website provides research support and software downloads. Part A says students use a browser to access the web pages. You have to explain the role of browser in this process. Okay, now in this process means, now it's not about the fact that you have to write that it creates tabs, it does this or that. You have to basically explain the role of browser in accessing the web pages. Basically the browser is responsible for sending the URL of the website which you write and the address bar to your domain name system, which is DNS, to obtain the IP address. Okay, the first function is done by the this browser, and then it connects to the web server using this IP address. Okay, so you can write these 2 steps first, or else I'll forget them. So you need 5 points. So number 1, I'm going to list them in order to make it more clear. So browser sends the URL to DNS, the domain name system, to obtain the IP address. Now the browser connects to the web server using this IP address. Okay, using this IP address. Now it also helps in displaying the web pages, and how it does that, it interprets HTML to display web pages. So you can write that it interprets HTML. You're just talking about the browser here, not the web server, so make sure you don't provide the details that the web server sends the signal back, or it sends a copy of its SSL certificate. I don't think you need to write it. You can also write the specific thing, which would be better. So browser sends the URL to DNS to obtain the IP address, and browser connects to the web server using this IP address, and it interprets HTML to display web pages. Okay, you can write that it manages this SSL and TLS certificate process. So you can write that. Okay, but not about the fact that the communication between the whole process of communication between the web server and the browser. But yeah, it does it manages the SSL and TSL certificate, sorry, TLS, it's transport layer security certificate process. And then for the 5th point, let me think, what does it do? It runs it retrieves cookies. Yes, it does. It retrieves your cookies which are downloaded onto the computer when you visit your any website. Okay, so it retrieves cookies. So any 5 valid points are credited in this case. Okay, now part B says the website owners are worried about DOS attack, denial of service attack. By the name, you can think about the fact that denial of service. Now you need to prevent it. Users are prevented from accessing a certain part of your website. It's notably an internet server. And what happens is that the user's web server is basically flooded with useless traffic, right? So what happens that the web server times out because web server can hold, or it can address it can basically address a set number of requests when it's flooded with useless traffic. So web server times out obviously, and users legitimate request is unanswered. So for 3 points you can write that it is an attempt at preventing users from accessing a certain part of a website. Okay, and what you can write that this is the first point you can write. Okay, and then you can write that users web server is flooded with useless traffic. So what happens that the web server times out, and users legitimate request is unanswered. So now you're denied of the service, so you can get 3 marks for this explanation. Okay, and then part C says that the website owners are also concerned about the ethical issues of copyright and plagiarism. So you have to explain that what is meant by the term copyright. It is basically a law that requires permission to use other people's work. So you just have to define it. It's somewhat a definition kind of thing, which you can get for 1 mark only. Okay, so you can write that a law that requires permission to use other people's work. Okay, then it says that state what is meant by the term plagiarism. So plagiarism is basically to claim other person's work as yours, as your own. Like you're copying someone's work but you're claiming it as your own. So to claim other person's work as your own. Okay, to claim other person's work as your own. So this was the definitions. Okay, so this was the last question probably, and thank you for watching this video. If there were any queries, you can ask in the comment section below, and don't forget to subscribe my channel. It would mean a lot, and thank you so much for watching. I'll see you soon with another video.